In this lesson, we are going to learn the rule of 68, 95, 99, 7. When we do this rule, it actually only holds true for normal curves, so symmetrical data. So to start, we're just going to kind of remind ourselves a little bit about skewed data. So if I'm going to sketch, it says sketch a density curve that is strongly skewed to the left. So I'm going to pick this. There's a curve that's strongly skewed to the left. On the curve, mark the location of the median and the mean and explain how you determine their location. So this is a review from our last lesson. No matter where you put the median and mean right now, I'm not going to be picky about where they are, just who comes first. So if I pick this as my median, where should my mean go? To the left or to the right? Hopefully you say to the left because the data is skewed to the left. So that's going to be my mean. Y, so when I answer Y for part B, I'm going to say the mean is pulled in the direction of the skew. And hopefully that kind of seems like review because we've talked about that in a few lessons now. So that's kind of one to go over there. Now in 2, you'll see we have, this is where our rule of 68, 95, 99, 7 comes in. This rule is true for normal data. It's something that was found to be true for all normal data. So if you're perfectly normal, this is always true. But if you are close to normal, we make these assumptions about the data. One thing you can talk about, I'm just going to think about when you go to the doctor, like if you go for a yearly physical, and they tell you where you are on the chart. Let's say the average height of a 17-year-old boy, and I'm totally making this up, so don't hold me to any of this. Let's say the average height of a 17-year-old boy is going to be 5'9". That's the average height. Well, so that would be our mean, right? We'll call that X bar. And this is, let's say, data collected through the state of Minnesota for years and years and years. Now, the standard deviation, we'll say is 2 inches. So if the standard deviation is 2 inches, I can say that, okay, here's the mean in the middle of this graph, isn't it? That's the mean. 5'9" is average. So I'm going to go up by 2 inches for each one of these. So I'm going to say after 5'9" comes 5'11", then 6'1", then 6'3". Going down, 5'7", 5'5", and 5'3". So what we'd say is true, see I went up and down my standard deviation, hopefully that made sense to you. What we know to be true now about normal data is that 68% of all 17-year-old high school boys in Minnesota would be between 5'7" and 5'11" in height. So 68%, that's a decent amount, right? They'd be between those two heights, which kind of makes sense. 95%, so that's within 1 standard deviation of the mean. 2 standard deviations of the mean is from here to here. So 95% of all 17-year-old boys in Minnesota would be between the heights of 5'5" and 6'1". And really, that's probably, we could hit 95% in our class, couldn't we? It would help if I used real data and didn't make it up. But you can think about that could be true. And then 99.7% of boys that are 17 would be, I went too far, sorry, would be between 5'3" and 6'3". Now, since I made this data up, don't assume you're in this category. But for someone to be 5'2" would be really rare, or to be 6'4". So if you were 6'4", you would tell people, oh, I'm actually really tall for my age. Because you are. 99.7 land between 5'3" and 6'3". You're way out of the norm. You're off the charts. You're to the right. 6'4" is really tall for your height. You're abnormally tall. A 5'11" boy wouldn't say, oh, I'm really tall for my age. You could say I'm taller than average because you are higher than 5'9", but you're not super tall for your age. You're within 68% of the data. So you're normal. I mean, that's not very off. That's how we use these curves here. We talk about what's normal based on that. Being normal for IQ scores, for ACT scores, colleges would look at this and they'll say, oh, the average ACT score is I have no idea, I'm just going to make a number up, 22, let's say. Well, if you're above a 22, you're above average. If you're below a 22, you're below average. So that's how we use these curves all the time. It's important to note, though, we can't apply the rule of 68, 95, 99, 7 unless we know the data is normal. We first have to be told it's normal or prove that it's normal by graphing it and looking at it. So let's do this actual problem now in your notes. That's just me going off on a tangent, right? This actual problem now, it says the length of pig pregnancies isn't always the same. Well, human pregnancies isn't always the same, right? In pigs, the length of pregnancies varies according to a normal distribution with a mean of 114 days and a standard deviation of 5 days. So here, I'm going to put my mean as 114 days. That's going to go right here. 114 is my mean. And since the standard deviation is 5 days, to be one standard deviation away to the right, I keep adding 5. And then to the left, I would subtract 5. So here, we now can make some decisions about, or answer some questions about pig pregnancies based on this distribution. And labeling the bottom, I think, really helps me. So the first question they ask is, what range covers the middle 95% of pig pregnancies? Well, 95% of the data would be 2 standard deviations away, right? Here's where 95% of the data is. So when they ask for the range, we'd say from 104 to 124 days. So if I'm a pig farmer and I have some pigs who are pregnant, I'm probably not going to leave town on vacation between days 104 and 124. A lot of my pigs will give birth. 95% of them will give birth in that time frame. So if I want to plan a vacation, I could plan earlier or later and be pretty confident, not for sure, but confident that I'm not going to miss that birth. But if in this range, I'm not going to leave town because I got to be home to give birth to the pigs. In B, it says, what percent of pig pregnancies are longer than 114 days? Remember, 114 is our middle, isn't it? Mean and median are the same. So how many data values lie here to the right? What percent of this should I be shading? Hopefully you realize since the mean and the median are our middle, 50% of pig pregnancies are longer than 114 days. If they asked how many were shorter than 114 days, 50%. So now that we have these percents in there, we're going to start to manipulate these a little bit more by using these percentages in here. So I'm going to erase this. You can see C. C asks, what percent of pig pregnancies are shorter than 109 days? So that would be from here all the way over to the end of the curve. So this whole area is what we're looking for. Well, I don't really know, right? I mean, there's no set percentage for that. So what I have to do is manipulate my data. I know that from here, the middle here, let's cut this in half. Everything to the right is 50%, isn't it? So I know this is 50%. Do I know this part right here that I'm dashing as dots here? This percent, I cut that 68% in half. So this dotted percent would be 34%. I'm cutting the 68% in half. So everything to the right of my shaded area would be 34 plus 50. So I'm going to do C up here so we can look at the graph. 34 plus 50 is everything to the right. So 84% of my data is to the right. But I'm actually looking for, so that's all this area. Let me shade it in green here. All of this, that's the 34. And then here's the 50 all the way to the end. That's the 84%. But I'm looking for the red. So 100% of your data values lie under this curve. I don't think I've mentioned that before. 100% lie under this curve. So I can take 1 minus 84, and you will find that 16% of your data values are going to be less or shorter than 109 days. So 16% of pigs are less than 109 days. Now you maybe came up with that answer a different way than what I just showed you. There are a couple ways, 2 or 3 ways you could manipulate this to get the same answer. I don't care how you come up with it as long as you get the 16. D then asks, I'm going to put this answer in here so we have it. D says, what is the median length of a pig pregnancy? Median length. So median is middle number, right? Since my data is skewed, or is symmetrical, excuse me, not skewed, my mean and median should be in the same spot, right there. So my When I had these listed out, I just accidentally erased them, sorry. When I look at that, my median then should be the same as my mean. So my answer for D is 114 days also. My mean and median are the same for symmetrical data. Okay, on the back now, number 3, we're going to go through a bunch of different examples and kind of learn how to manipulate these percentages. So 3A, we have the data here. We don't know what we're talking about, which is fine. But it says what percent of data will fall below 0 standard deviations. So they're looking for this part right here, from here to here. What percent of the data is that? Hopefully you see, since this is our middle, that'd be 50%. Just like if they asked what percent of data will fall above 0 standard deviations, 50%. In B, it asks what percent of data will fall 1 standard deviation below. So here's 1 standard deviation below. From here to here they're asking for. Well, this is the one we just did, isn't it? Remember this here? This is 16%. Oh, excuse me. I just gave the answer. This is 34%. All this to the right is 50%, which makes this little piece right here the 16%. That's the one we just got done doing. So 1 standard deviation below, data will fall below 1 standard deviation. So when you're looking here, this one actually, I just did backwards, didn't I? I took 1 standard deviation below. Let me start this one over. They want +1. I use -1. Right here, this is what we're looking for. 1 standard deviation below. So from 1 to everything below. So, same idea though. This is 34%. This would be 50%. This all right here, right? So it's actually 84%. If they ask for above 1 standard deviation, this part right here would be the 16%. And this is always going to be true, so you can look back on these and double check stuff. How about fall above -2 standard deviation? So now they're giving me the negative. -2. So to fall above -2 means I'm going to go from here all the way to the end. So let's see. I'm going to divide this in half, and I'll play around with this. I know all of this is 50%, right? And I know from here to here would be half of 95%. 95 divided by 2 would be 47.5. So that's half of 95, right? So if I add those together, that should be all these values. So it's not this stuff. I'm not looking at this. I'm looking at everything else. So we take the 47.5 plus the 50%, and we get 97.5% of all values will fall above -2 standard deviations away. Next one, below 3 standard deviations. So here's my 3. So look at this. That's from here to here. So this is going to be a really small number here, isn't it? I mean, that's barely anything. So from here to here, again, I'm going to cut this in half, and I'll say, okay, everything over here is 50%. This part from 0 to 3 would be half of 99.7, wouldn't it? Half of 99.7 is 49.85. So I'm going to have to add the 50 plus 49.85, and I get 99.7. Excuse me. I get 99.85. So again, I took my 99.7 divided by 2, and I got 49.85. And then I added that to the 50. So I'd get 99.85. So that means this little piece is just a 0.15. So if they ever ask for 3 standard deviations above, it'd be 0.15. And so you might want to write that so you have this, so you can look back on these notes in case you're asked that kind of stuff. 3 standard deviations above would be 0.15, because it'd be a 100 minus that. E, it says below -1 standard deviation. So we did this one already. This is the one I accidentally started with. This one we've done a couple times, so hopefully you're going to start to memorize this. But remember, if we draw this in, this is 50%, This is half of 68, so 34%. So all of this would be 84%, which makes 1 minus 84%, the 16%. So 16% lie there. And the last one, above 2 standard deviations. So above 2, that's right here. Now, we've already found below 2, haven't we? Well, not really, I guess. We probably should pretend like we haven't, because we're going the other direction. But C kind of helps us with this one. So if you look at C, C's a lot like this one. We found the other piece. But now if we're looking at this, we know that this right here, this amount right here is 50. I'm going to do it a different way here. And from here to here is 95% of the data. So this would be 47.5. So if I take the 50 minus the 47.5, I should get this little piece right here that's shaded. And when I do that, I get 2.5. So 2.5% of values lie above 2 standard deviations. So why we want to know this, just to kind of put it in context, let's say my height is in this area here. I know then that only 2.5% of the population in my age group or my gender or whatever it is lie in this category, only 2.5%. So I am tall for my height, for my gender, for my age, whatever it would be. I know I actually am pretty tall, only 2.5% of people are in there. If it's 75% are in that category, I'm not tall. Most people are that height. So you kind of put things in perspective when you're talking about the normal. You're going to do a worksheet with this tomorrow. Oh, I have an extra one on here. I think we already talked about those, though. Those I don't have in the thing. So you're going to do a worksheet tomorrow, and when you finish that, or before you start that, if you have any questions and you need help with the percentages, make sure you let me know.